What's up, street racers? Today, we're going to talk about probably one of the most confusing types of factoring, so you're going to have to buckle up. That's why you're street racers, because you always wear a seatbelt. So we're going to talk about complex factoring today, and it do be a little complex. I never liked this name because complex means something else in math, but that's for another day. So, what complex factoring is for is when we have a number in front of the x squared. Simple factoring was x squared plus 5x plus 6. There wasn't a number here in front, so this was really simple to factor. GCF factoring was when we had like 8x squared minus 4x, when we just had some stuff in common that we could take out. And then factoring by grouping was when we had something like this, where there were 1, 2, 3, 4 terms. Today, we're going to have a 3-term trinomial. That's what the tri is for. But we're going to have a number in front of the x squared, and that's going to goof things up real bad. So we need complex factoring to take care of that. So let me explain to you how to do it. Then I'm going to tell you a beautiful allegory, which is a fancy English word for a story meant to teach a lesson. And then I'll do some examples with you and look at some harder ones. All right. So let's start by looking at this, which kind of tells you how to do it and what to be looking out for. So you need to know, first of all, how do I know when to do complex factoring? This method is used when there are 3 terms and A does not equal 1 and you can't factor out a GCF. So basically what that means is when you have something like 3x squared plus 5x minus 2. When you have this number in front of the x squared, then you're in big doo-doo and you've got to use complex factoring. So you're looking for a number to be in front of the x squared. Here's what we're going to do. We're going to cheat a little bit. We're going to multiply a, which is the number in front of the x squared, to c. And then whatever that is, we're going to do simple factoring on that. Then we're going to divide the numbers that we get from that by the original a. We're going to reduce those fractions if we can and move the denominators to the front. Okay. You should copy down these steps because they're very important, but I'm going to tell you a story to help you remember them. All right. So let's go look at that allegory, shall we? So this is a problem that we have to do complex factoring on, and we know that because there's 1, 2, 3 terms, and there's a number in front of the x squared. So complex factoring is something that I like to think of a lot like the way teenagers think of dating. So I want you to picture a world where 4 and x squared are in love. They're dating. They're romantically entwined. However, 4 is getting a little tired of x squared's baloney. 4 is starting to look at x squared and think to him or herself, or themselves if they're non-binary, whatever 4 is into. They say things like, x squared doesn't appreciate me. X squared only plays FIFA and Fortnite all day. X squared's been looking at their phone and smiling too much, and I didn't text them. So x squared, or rather 4, gets the idea that they can do better than x squared. So 4 does what any of you would do in a relationship when they feel underappreciated or they feel like they're being lied to. You mean they talk it out like grown-ups, Mr. Barton? No, children. 4 cheats on x squared. So 4, knowing they can't do the cheating in front of x squared, goes over to -6's house. And they cheat. And you know what cheating I mean. The kind of cheating that makes you kind of multiply. If you catch my drift. So 4 moves to the back and multiplies with -6. X squared stays at home. 5x lives somewhere in the neighborhood. They're just hanging out for right now. And 4 multiplies with -6. Now, you know 4 can't just go over to -6's house, do the deed, and then keep it quiet. No. 4 is a teenager. So 4 has to take a picture, a selfie, hanging out with my BFF, -6, heart eyes emoji, and then they post that thing all over social media. They post a TikTok with -6. They post them on their Snapchat with -6. They post it everywhere. And X squared finds out. And X squared has some self-respect. So they don't just say, hey, -4, what's this about? I mean, what's going on? I mean, I know you and -6 are tight and you're homies and all, but you know what? This makes me a little uncomfortable. No, X squared says they've had enough and they break up. So what is breaking up? We're going to break this whole friend group up. We're going to factor it. So now we factor. I mean, what 2 numbers multiply to 24? There's 1 and 24. There's 2 and 12. There's 3 and 8. Oh, 3 and 8 will add up to 5 if I make the 3 negative. So this is going to factor to x minus 3, x plus 8. So there we were. X squared had been found out that 4 cheated on him or her with -6. They broke up. X squared was devastated, a shadow of his or her former self. And then 4 realizes, oh no, I've made a horrible mistake. I was in love with X squared. X squared was the greatest thing that ever happened to me. I'll never forget the first time I brushed my lips gently across X squared's in a loving embrace. It's like... Anyway, you get the idea. So, 4 has the beautiful idea that they're going to fix things with X squared. So, 4 thinks to themselves, if I mess this whole thing up, multiply, by multiplying with -6, I cheated. Maybe I can fix it by uncheating. So 4 gives X squared the look and goes, hey baby girl, what's up shawty? How about I come over and uncheat? And then gives them the old wiggle eyes, you know what I'm saying? So we're gonna uncheat. If multiplying was cheating, what do you think uncheating is? Dividing, that's correct. So we're gonna divide. So we're gonna divide. 4's the one that did the cheating, so 4's got to be the one to uncheat. All right, so here, it works just fine. 4 goes into 8 2 times. X plus 2. Here, though, oh no, our relationship got hard again. You know what I mean? Things got hard here for 4 and X squared because X squared started asking for, reciprocity, loyalty, and respect. Here, I can't think of anything more frightening or difficult than fractions. I know a little thing about teenagers. Their 3 greatest fears in life are being honest with themselves, commitment, and fractions. So if you can't handle commitment up here, I know you can't handle fractions down here. So rather than deal with this fraction, we're going to do what we did last time we faced one of our 3 greatest fears, commitment. We're going to cheat again. So instead of dividing, 4 says, no way, this is too hard. I tried to uncheat, but this isn't for me. I'm going to cheat again. So we're going to just move the 4 in front of the x and multiply it to the x instead. 4x minus 3, and we avoided our problems. So this is the answer. That's factored. If you multiply these back together, you'll get this. I mean, in summary, 4 ended up with x, which is like x squared's uglier, less friendly cousin. 5x is nowhere to be found. They moved out of the neighborhood. And 6 was torn apart. 6 was devastated by the entire encounter. And that's how you do complex factoring, children. All right, so let's go ahead and do a couple more examples without all the metaphor and song and dance, as much fun as that is. Let's do a couple of these with just multiplying, factoring, dividing, and then moving the denominator forward if it doesn't simplify. So let's look at this one. Step 1, take the front number and move it to the back and multiply it to the back number. So the x squared comes down, so does the plus 9x. 2 times 4 is 8. Now we do simple factoring here. So we look at 8, its factors are 1 times 8 and 2 times 4. To get a 9, we need 1 plus 8. So this is going to factor to x plus 1, x plus 8. Now we have to uncheat. We have to divide by this original a term. So we divide by 2, divide by 2. Here, 2 doesn't go into 1, so we move it in front of the x. 2x plus 1. Here, 2 does go into 8, so we reduce that fraction. 2 goes into 8 4 times. X plus 4. And that's your answer. All right, one more. Take the a term, move it to the back, and multiply. Bring down your x squared. Bring down your negative 17x. 3 times 10 is 30. Now we look at our factors of 30. We have, whoops, I don't need that. 1 times 30, 2 times 15, 3 times 10. Oh, I think we found it already. We could use that one. There's also 5 times 6 in case you care. But we're going to use 2 and 15 because that'll get us 17. But it's negative, so we need these both to be negative. So this is going to simple factor to x minus 2 and x minus 15. Let's just check real quick. Negative 2 minus 15, negative 17. Negative 2 times negative 15, positive 30. We're good. Now we divide by the original a term. So we're going to divide by 3. 3 doesn't go into 2, so we move it in front of the x. So we have 3x minus 2. 3 does go into 15 5 times. So x minus 5. This is our answer. And then you're done complex factoring. And that's it. I will give you, let's talk about something real quick. Let's say we've got something, we do the multiply, we factor, and then we get something like this. X plus 4, x plus 12, and then the original one here was a 6. So I have to divide by 6. Okay, we're pretending. This is a new problem, of course. Okay, let me show you a thing that you have to be aware of here, otherwise it's going to get messed up. 6 does not go into 4. Okay, but this reduces to 2 over 3. You have to reduce, then move the 3 in front. If you don't, you'll get the wrong answer. So there is our correct answer, but yeah, if you don't, it'll get goofed up. So you got to be careful there. Okay. All right, we've got 2 more. What if there's a GCF? So much like our story where 4 and x squared are cheating on each other, really just 4, but you know how rumors spread. If there's a GCF, what we're doing here is not really like kosher math. It's a little fishy. We are cheating. You can't really just take this number and multiply it to the end because the problem is hard, right? That's not really how these things work. So you are, in fact, cheating a little bit. And this process that I'm teaching you erases GCFs. Okay? So here, there's a GCF of 2. If you try and do this process, multiply this here, we get x to the 4th plus 26x cubed plus 144x squared, and so on. If you do this process without taking the GCF out first, the GCF gets erased, and then the whole thing is wrong. Because remember, it's like your little brother. It doesn't do anything important for the problem, but if you lose it, your mom is gonna be livid, and then she's gonna whoop your butt. So we can't lose the GCF. So it getting erased is a problem for us. The way we prevent that is by taking it out as the first step. So for this problem, we're gonna take out a 2 and an x squared because all of these have an x squared in them. So 2x squared, 2x squared, 2x squared. The 2x squared is our GCF and it goes in front. 2 goes into 12 6 times. We had 4, we took out 2, there's 2 left. 2 goes into 26 13 times. We had 3 x's, we took 2 out, there's 1 left. 2 goes into 12, still 6 times. We had 2 x's, we took them both out, no more x's. Now, we do complex factoring on this. So we're going to do this whole process to the stuff in the parentheses. Don't forget to put this 2x squared on your answer at the end, though. It's your GCF, it's your little brother. You have to take it to the mall with you, and you can't lose it. So let's factor this. Multiply the 6 to the end. X squared plus 13x plus 36. We look at the factors of 36. They are 1 and 36, 2 and 18, 3 and 12, 4 and 9. Oh, 4 and 9 will give me a 13. There's 6 and 6 if you care. But we're going to use 4 and 9. This factors to x plus 4 and x plus 9. Now, we divide by the original a term. And when I say original a term, I don't mean original, the 12 up here. I mean the term that we multiplied to the back, so the 6. So divide by 6, divide by 6. Remember, reduce, then move the denominator. This reduces to x plus 2 over 3 because 2 goes into 4 and 6. This reduces to 3 over 2 because 3 goes into 6 and 9. Now we move the denominators in front. So we have 3x plus 2 and 2x plus 3. And then we bring our little brother all the way down because we're not allowed to forget the GCF. And this is your answer. Whew, what a problem. Look at that. 1, 2, 3, 4, 5, 6 steps. Oh my gosh, you guys are doing big kid math. All right, let's look at this one. I promise this one is not 6 steps. It's a little bit better than that. So GCF, we can take a 10 out of all these because they all end in 0. So we're going to divide by 10. So 10 goes in front. We have x squared plus 13x minus 7. Now we try and factor this. Notice there's nothing in front here. There's the 1. But because it's just a 1, we don't need to do complex factoring. We can try simple factoring. So we look at the factors of 7. 7's factors are 1 and 7 because it's prime. But wait a second. I can't make 13 with 1 and 7. At best, I can make... Oops, I gave it away. I can make 8. Because I cannot make 13, this is unfactorable, and this is as factored as it can get. So we don't actually have to do complex factoring there, but we're just refreshing GCF a little bit. Sorry to scare you. All right. I hope that video was enjoyable for you. I always love this lesson. It's one of my favorite ones, honestly. It's one of the funniest lessons I get to teach all year. So make sure, give me a little like on that video. You know, I did some really great YouTube acting there. I think you probably had a little chuckle. If not, you're probably like, I hate this class. This class is whack. But if you got a little chuckle, make sure you give me a like and subscribe. You know what I'm saying. All right. Have a great day, ladies and gentlemen. I'll see you next time.